Alrighty, Zach, welcome to lesson 80. Today's lesson is going to be super fun if you like scientific notation. And who doesn't, huh? Okay, I know it's not everybody's favorite thing, but it does allow us to do math with super big and super small numbers. So that's what we get to do today. First, let's look at this comic. They're saying, well, I guess that explains the abdominal pains. Looks like a bunch of surgeons, right, operating, and they pulled this porcupine out of someone. Ow! How did that get there? Okay. Well, that would explain the abdominal pain. I guess it would. All right, let's jump into the lesson, though, because I know you want to just get this math done with. Let's do this. Let's get on with it, right? So, scientific notation. It's actually useful, turns out, in problems where you need to multiply or divide very large or very small numbers. So first we're going to talk about multiplication. All right, so we're going to multiply two numbers using scientific notation. Here we go. The first step is we write both of the numbers in scientific notation. So we're going to multiply this. It looks like 4 million times 20 million. All right. Let's say you've got a couple bank accounts. No, that would be adding. You want to multiply your bank accounts and they have this much money in. If you multiply them together, how much money do you have? Oh man, that would be a lot of money. The first step to figuring out a problem like that, because you don't want to have that much money and not know how to multiply them, right? Okay, so the first step is to write those numbers in scientific notation. Let's start with 4 million. All right, so if we focus on the 4 million, we want to put the decimal right here. Okay, so we have to figure out, what do we multiply it by? It would be 1, 2, 3, 4, 5, 6. So it would be 4 times 10 to the 6th. Okay, what about 20 million? We want the decimal point to always be one space past the first non-zero number. So here we go. We want it here. 1, 2, 3, 4, 5, 6, 7. So it's actually going to be 2 times 10 to the 7th right there. So that's what 20 million turns into. So now we're multiplying two numbers, which are 4 times 10 to the 6th and 2 times 10 to the 7th. So our problem has turned into this one, 4 times 10 to the 6th times 2 times 10 to the 7th. And this is actually really cool and really easy, because what you're going to do is you're going to pull out this 4, put it here. You're going to pull out this 2, put it here. This is the same as 4 times 2, okay? 4 times 2 go in there. And then you multiply the tens part in the next parentheses, because you can do that. Commutative property of multiplication doesn't matter which order you do it into, right? So you're doing 4 times 10 to the 6th, 2 times 10 to the 7th. So just pull out the 4 and the 2 and do 4 times 2 here and 10 to the 6th times 10 to the 7th here. Okay, so what does that turn into? 4 times 2 obviously is going to be 8 right there. And then this 10 to the 6th times 10 to the 7th, I don't know if you remember, if you are multiplying things with exponents, what do you do with the exponents? Turns out you add them. So it's going to be 8 times 10 to the 13th. Look at that. You did all of that work and you didn't even need a calculator. And you got the right answer, which is 8 times 10 to the 13th. Now, you could add a bunch of zeros and figure out where exactly that 8 goes, but that is the answer. Okay? Sweet, right? Let's do the next example. And remember this rule here that this young lady is pointing out to us. First, we're going to write the numbers in scientific notation. Then we're going to multiply. That is the key to all these problems. So example 80.1, here we go. We have two things to multiply together. This is the first one, 0.003 times 10 to the negative 4th. Oh, times 10 to the negative 4th. Why did they do that? They didn't even write it in scientific notation. So we need to fix this. We need to fix that number. That's going to be step 1. And then 2 times 10 to the 20 actually is already in scientific notation, so that's useful. But we need to fix this one. Okay, so it should be, the decimal should be right after the 3. So it's going to be 3 or 3.0 times 10 to the 1. How many times do we need to move that decimal point? Let's figure it out. Okay. 1, 2, 3. So what do we need to do here? And sometimes I mess that up too, and I do it in the wrong direction. Like, do we need to add 3 or subtract 3? So I don't know how to make it easier to remember, but I'm making this number bigger, so I'm going to make this smaller. So I'm going to do 3 times 10 to the minus 7, because minus 7 is more to the left on the number line than minus 4. Okay, so either way, like when you're making this number bigger, I make this one smaller or more to the left on the number line. So anyway, that is this number now in scientific notation, okay? And then, so we have this number, and the second number is already written in scientific notation, so I'm just gonna rewrite it, 2 times 10 to the 20. Okay, now we multiply. So we're gonna pull out the 2 and pull out the 3. So we're gonna have 3 times 2 in one parentheses, and in the next one we have 10 to the minus 7 times 10 to the 20th. Okay, so 3 times 2 is going to be easy peasy because that's 6. And then we have times 10 to the what? And what do we do to these exponents? We need to add the exponents whenever we're multiplying. So it's basically negative 7 plus 20, which is 13. 20 minus 7 is 13. So it's 6 times 10 to the 13th. This is kind of nice because you don't even need a calculator and you're actually multiplying humongous numbers and tiny numbers. So that's the answer there. Let's do example 80.2. This is, I thought of this because I was like, would I rather die slowly cut into 1,000 pieces, or would I rather keep doing math in scientific notation? I don't know. It's a tough call. I think I'm going to keep doing the math though. Or you can die slowly, cut into 1,000 pieces. Let's just keep doing the math. All right, so we have 2 numbers here, and they've made it very difficult because none of these are in proper scientific notation. Shame on them. Shame on them. What do we need to do? So I'm looking at this 4. The decimal should be here. So instead of here, it's way over there. 1, 2, 3, 4, 5 spaces. So I need to bring that 5 spaces over. I'm making this number bigger, so I'm going to make this 5 smaller. So it's going to be, let me get a different color so it's not confusing. 4 times 10 to the minus 10. Okay. Now, what about this number over here? We have 700,000. But I don't want 700,000. I want 7 times 10 to the something, right? So what does it have to be? 1, 2, 3, 4, 5. 7 times 10 to the 5th. Okay, put parentheses there, and that's what I have. So now I can pull out this 4, pull out this 7. Okay, so I've got 4 times 7 in one set of parentheses. That's going to be easy. That's just 28. And then I've got 10 to the minus 10 times 10 to the 5th. Okay, so I'm going to have 28 times 10 to the, let's add these exponents. Negative 10 plus 5 is going to be negative 5. But this answer, you'll notice, is not written in scientific notation because the decimal is not in the proper place. So we need to change it to 2.8. Now I'm making this number smaller, so I'm going to make this number to the right on the number line. So it's going to be 10 to the minus 4 because I moved it one spot over, so this just needs to move by 1. And I moved it 1 to the right on the number line. Sweet. Okay, that's it. Easy peasy, right? Now let's talk about division. We've conquered multiplication, but now we need to divide and conquer. Ha, get it? All right, let's divide and conquer. So division. So when we're doing division, it's a very similar process. And you can write the numbers in scientific notation, and then you sort of handle the powers of 10 separately than the other numbers. Okay, so let's just try it out. Let's say you have 2 humongo numbers like this that you want to divide. So let's put them both in scientific notation. Okay, honestly, Zach, if it were me, what I would do with this problem is anytime there's a 0 on top and a 0 on the bottom is I would cancel that out, and then I'm left with 20 divided by 4, which is 5. I already know that the answer to this problem is going to be 5. But that doesn't help us solve scientific notation problems, so let's just go through it and pretend that we don't know that the answer is already 5. What would this number on top be? It would be 2 times 10 to the what? Well, the decimal's here and we want it way over here. So let's count. 1, 2, 3, 4, 5, 6, 7. So that's going to be 2 times 10 to the 7th on top. What about on the bottom? The decimal is here and we want it way over here. So let's count. 1, 2, 3, 4, 5, 6. Okay, so it's going to be 4 times 10 to the 6th on the bottom. And then we just divide. So 2 divided, let's do this part first. 2 divided by, okay, well, actually, let me write it out. It's basically 2 over 4. You do that separately. And then you have 10 to the 7th over 10 to the 6th. Okay, make sense? All right, now what does that give you? Well, the 2 over 4 gives you 0.5 or a half, whatever. And then the 10 to the 7th over the 10 to the 6th. Now, when you are dividing things with exponents, what do you do with the exponents? You're going to subtract them. So it's 0.5 times 10 to the 1. Times 10 to the 1 just means times 10. You don't even need that one there because it's just times 10. So if it's 0.5 times 10, it's 5. Which is the answer we got at the very beginning, to remind you of that, but that's okay. We're going to go on and we're going to do another one. You're probably feeling a little bit like the guy on Live, Die, Repeat, like because I'm making you do all these examples over and over and over. It's like you're living the same horrible day over and over and over, but that's okay because you're learning something as we go, right? Just like the guy in the movie. So example 80.3 wants us to divide this number by 400,000. Don't just put that in your calculator. I know, what were you thinking? Let's do it the scientific notation way, all right? So let's look at this number. The decimal's here, we want it here. So it's 1, 2, 3 out of place. So let's do 1.6 times 10 to the, now I made this number bigger, so it's gonna be -3. Times 10 to the -3, right? Okay, now what about this 400,000? So the decimal is here, we want it here. So how many times do we have to move it? 1, 2, 3, 4, 5. So this is going to be 4 times 10 to the 5 because I made this number smaller, so I have to make this a big number to multiply it. All right? Okay, so now we are, but we're dividing. We're dividing, so this is actually a fraction. Oh, okay. All right, we can handle that. Forgot we were dividing. So let's take this number and put it right there and draw a divide sign. Now this is our problem. Okay, so we're going to do the numbers at the front a little separately than the others. So it's 1.6 over 4. Then you have 10 to the -3 over 10 to the 5. Okay, what's 1.6 divided by 4? It's basically 16 divided by 4, but then you've got that decimal, so it's going to be 0.4 times 10 to the what? So when we divide -3 and a 5 here, -3 minus 5 puts you at -8 on the number line. So it's 0.4 times 10 to the -8, but that's not written in scientific notation. No one's going to accept that answer. We've got to put it in scientific notation. So let's make this number bigger. So that means this number is smaller. So if it's smaller, it goes more to the left on the number line. So there you go. That's the answer. Final answer. I'm not taking it back. I'm standing with it. Okay, so here we go. Let's talk about multiplication and division. Oh boy, here we go, right? Yeah, so we hit multiplication, we hit division. Now what about both of them? Put them both together in one, and what do you get? You get a problem that looks like this. All right, easy peasy. What are we gonna do? First, let's put everything in scientific notation. Let's start with this one. Let me get a red so we can see it better. This is 0.06 times 10 to the 5th. Who would write something like that? We don't want that. We want 6 times 10 to the what? Well, the decimal was here. I moved it 2 places. I made that number bigger, so I got to make this one 2 smaller. So it's going to be 10 to the 3. Okay, so that's my first term. Now, the next one is this one. Let's go with 300,000. This is going to be 3 times 10 to the what? Well, the decimal is here. We want it here, so we're going to go 1, 2, 3, 4, 5 times 10 to the 5th. Okay, now let's go to the bottom. We're going with 1,000 right here. Now, we could just keep it 1,000, but we're learning scientific notation, so we're going to move the decimal from here to 1, 2, 3 here. 3 spaces to the left. So this is 1 times 10 to the 3. Okay, easy peasy. What about the next one? It's going to be 9 times 10 to the something, right? So this one, let's see, the decimal's here. We want it here. We're going to go 1, 2, 3, 4, 5. 9 times 10 to the minus 5, because that number is getting quite a bit smaller right there. Okay? So that's our problem. Now we've turned everything into scientific notation. It doesn't look better, does it? Except for it could be better if you just take out all those first numbers, because then you have 6 times 3 on top, 1 times 9 on the bottom. And then you have, whoops, I don't want to do that. I want to do all the 10s. 10 to the 3rd, 10 to the 5th, 10 to the 3rd on the bottom, and 10 to the minus 5 on the bottom. Okay, so what do we do with this? All right, let's multiply this out first. 6 times 3 is going to be 18 on the top, 9 on the bottom. Then you have, let's simplify this. When we multiply, we add them together, right? So it's going to be 10 to the 8th. 10 to the 8th on top. And on the bottom, we're also multiplying these together. So we're going to add 3 minus 5, and it's negative 2. So it's 10 to the negative 2. Okay, now we've got a problem we can work with, right? 18 divided by 9 just simplifies to 2. So I'm going to change that to a 2. Now what about this part? 10 to the 8th over 10 to the minus 2. When we divide, we're going to subtract. So 8 minus a negative 2 is going to be 8 plus 2, which is 10 to the 10th. So this is going to be times 10 to the 10th. And that's our answer. Final answer. Not changing it. That's what it is. All right. Simple math, right? Yeah, simple math. Doesn't get any more simple than that. Oh boy, it does get more complex though. Let's do example 80.4, which says to simplify this complicated thing. This is a monster. This one's a monster, I'm not going to lie. But we can handle this monster one step at a time. We are going to tackle everything and put it in scientific notation. Let's start with this one. Okay, we want the decimal here. 1, 2, 3, 4. 4 spaces. I'm going to make it bigger. 7 times 10. So I'm going to make this smaller by 4. Minus 27. Okay? Now, let's look at this one. 4,000 times 10 to the 6. Why would they do that to us? The decimal's here. We want it here. 1, 2, 3. I'm turning 4,000 into 4, so I'm making it bigger to smaller. This has to get smaller to bigger. So it's going to be 4 times 10 to the 9th. Okay. Now, let's tackle these on the bottom. we've got this 0.00004. Why would they do that? Again, we want the decimal here. It's back here. We're going to go 1, 2, 3, 4, 5. So it's going to be 4 times 10 to the minus 5. Okay, what about the next one? This is going to be 7 times 10 to the 6th because it moves 6 places. 1, 2, 3, 4, 5, 6. Okay. Now, let's pull out all of the base numbers. I guess you could call them these base numbers in front. All right. So we're going to have, and let's get a different color, 7 times 4 on the top, 4 times 7 on the bottom. Oh, that's convenient. That's all going to turn into 1. Okay, and then we're going to have 10 to the minus 27 on the top. Well, I guess let's just do that. 10 to the minus 27 and 10 to the 9th on the top. I'm pulling out these numbers. Okay, and then on the bottom, I'm going to pull out 10 to the minus 5th and 10 to the 6th. All right, how does that simplify? Oh, this shouldn't be an equal sign here. This should be a multiplication. All right, but that's okay. 1, all of this goes to just 1 because all of that cancels out. And then you've got 1 times what? 10 to the, when we are multiplying, we're adding the exponents. So negative 27 plus 9 is going to be 10 to the minus 18 on top. What about the bottom? This 10 to the minus 5th and 10 to the 6th, when we multiply, we are adding the exponents. So 6 plus negative 5 is going to be just 10 to the 1. So divided by 10 to the 1, which is just a 10. All right, so 10 to the negative 18 over, when we divide, we are subtracting. Negative 18 minus 1. So this all turns into 1 times 10 to the minus 19. Bam, easy peasy, and that is simplified. One more example. Hang in there. Hang in there. You got this. One more example, and then you can go on and do it 30 times in your homework. Okay, no, but seriously, you got to know this stuff. All right, let's turn to the next page. Do example 80.5. This is the last one. We got this. We got this. Don't let this trick you. This is not in scientific notation. You need the decimal point there. All right, so we want it here. It's actually here. We're going to make this number smaller. 2 times 10. So this one's got to be bigger. So it's going to be negative 44. Okay. Now, let's tackle this one. 400 times 10 to the 20. We want the decimal 1, 2 there. So it's going to be 4. We moved it 2 spots. We made this number smaller, so this has to get bigger, times 10 to the 22nd. Okay, what about the bottom? We've got this number, 100,000. We want the decimal here. 1, 2, 3, 4, 5. It's going to be 1 times 10 to the 5. Okay, what about this number? We've got the decimal here. We want it here. 1, 2, 3, 4. We moved it 4 spots. 8 times 10 to the, I made this number bigger, so I got to make this smaller. 4 smaller to be precise, so it's going to be minus 19. Okay, now we got it to here. Let's pull out all these base numbers, the 4, the 2, the 1, the 8. So that's 2 times 4 on top, 1 times 8 on bottom. Check it out, another 1. That's going to be equal to 1. But we'll leave it at that for now. So on the top, now let's pull out the tens. We've got 10 to the minus 44. We've got 10 to the 22, okay, multiplied together. And then on the bottom, we've got this 10 to the 5th, 10 to the 5th. Then we've got this 10 to the negative 19. So let's pull that out, 10 to the minus 19. Okay, so 2 times 4 over 1 times 8, that's 8 over 8, which is 1. Okay, now let's tackle this monster. When we multiply, we are adding exponents. So negative 44 plus 22 is just going to be negative 22 now. So we've got 10 to the negative 22 on top. What about this? Let's tackle this monster. When we multiply numbers, we are adding their exponents. 5 plus minus 19. And you get 10 to the minus 14. Okay, now we did multiplication. Now let's do division. When we divide numbers, we subtract their exponents. Negative 22 minus a negative 14. So that's negative 22 plus 14. And we end up with 1 times 10 to the minus 8. Bam! That's your answer. That is it. And you can do this. I know it's hard. Doesn't seem like you can make it. You can make it. Good job, Zach. Hope you enjoy your math today. Love ya. Bye.